Hey guys, so today we're going to start talking about special right triangles. I'm going to move this forward some. Special right triangles. So there's going to be several things that you're going to need. I have this additional notes page, which will be very helpful. I've got this notes page that you'll be writing on as we fill these out. And then I've got the worksheets. So make sure that you get that from me. If you go to the calendar, you'll see on special right triangles, if you click there, it'll be special worksheets for Wednesday through Friday. So you'll want to click on that. The very first is the additional notes page, but it didn't copy very well. So that's going to be probably really hard to see. Hopefully you can pull it up, but otherwise get a copy from me. And then I also have all the worksheets there. So if you're at home, hopefully you can print those if you need to, or make sure that you get copies from me. Okay, so today we're going to start by talking about special right triangles, and we're going to start with the 45, 45, 90. So on this notes page, make sure you're on the side that says 45, 45, 90. If you don't have this notes page, you can always write it down. Okay. So, very, very important lesson. So a 45, 45, 90 triangle is based on a square where every side is 1. If we were to draw in a diagonal in a square, that's going to cut that 90-degree angle in half and create two 45, 45, 90 triangles. So I've got my 45, 45, 90, 45, 45, 90 triangle. So what if we just do the Pythagorean Theorem to find the length of the diagonal? So since we don't know the hypotenuse, we would add 1 squared plus 1 squared under the square root. So 1 squared plus 1 squared, you'll see that that is radical 2. So by Pythagorean theorem, I know the hypotenuse is radical 2. So on all 45, 45, 90 triangles, the sides are 1, the hypotenuse is radical 2. But not all side lengths are 1. What if we have a side length of 5 or 20 or whatever? So on a 45, 45, 90 triangle, since two angles equal each other, that means that the two sides will always equal each other. So I just labeled them X there. The hypotenuse is always whatever the leg is times radical 2. So let's look at some examples. So say this side is 4. Well, on a 45, 45, 90, the legs are the same. So if this side is 4, that's going to make this side 4. The hypotenuse is always whatever the leg is times radical 2. Well, if you were to type in your calculator 4 times radical 2, it's just going to be 4 radical 2. So it's always just what the number is, radical 2. 4 radical 2. A radical is kind of like doing an x. Like if I said 4 times x, it would be 4x. 4 times radical 2 is 4 radical 2. Okay. So let's try some examples to make sure you got it. So if this leg is 9, that would mean this leg is 9 because the legs are the same. The hypotenuse is always what the leg is times radical 2. So 9 radical 2. So look at this one. If this side is 2, what would this side be? 2. Hypotenuse is leg times radical 2, so 2 radical 2. But let's do a few with radicals. So this leg is 3 radical 2, which is going to make this leg 3 radical 2. Well, when I do 3 radical 2 times radical 2, the radical 2's are like terms, so I can multiply what's under the radical together. So that would make 3 radical 4. But do you know what the square root of 4 is? That's right, it's 2. What's 3 times 2? That would be 6. Now, you can always do that in the calculator. If I did 3 radical 2 times, so I have to tab out to hit times, so that way it goes out from underneath the radical, times radical 2, I get 6. So it tells me what that is. Let's try this one. Multiply 3 radical 5 times radical 2. 3 radical 5 times radical 2. Now we can only multiply what's under the radicals together, so that would be 3 radical 10. 10 is not a perfect square, so that's just my answer, 3 radical 10. Again, you could type that in the calculator and get that too. Let's try this one. If this leg is radical 7, that means this leg is radical 7. What do you think radical 7 times radical 2 would be? What do you think? Radical 14. That's not a perfect square, so we just leave it. So legs are always the same on a 45, 45, 90, and I remember that because two angles are the same. So if two angles are the same, the two legs are the same. The hypotenuse is always the leg times radical 2, and I remember that because there's two 45 angles. But what if, we got to go backwards. What, do you like my little back flippy guy? What if we know the hypotenuse? So say you know the hypotenuse. In order to go backwards, instead of multiplying by radical 2, you would need to divide by radical 2. So if my hypotenuse is 3 radical 2, 3 radical 2 divided by radical 2 would cancel out those radical 2's, and I would just be left with 3, which hopefully that makes sense because the legs are the same, 3 and 3. The hypotenuse would be the leg times radical 2, 3 radical 2. So it's easy if there's already a radical 2. So let's try this one. So if this is 6 radical 2, what is 6 radical 2 divided by radical 2? Well, the radical 2's will cancel, and each side would be 6, which hopefully makes sense. The legs are the same. Hypotenuse is the leg times radical 2. So what about this one? 11 radical 2 divided by radical 2 would be 11. So the sides would be 11. But what if there's not a radical 2 next to it? Let's talk about that. What if there's like an 8? So if I do 8 divided by radical 2, let's see what happens in the calculator. 8 divided by radical 2. It is 4 radical 2. 4 radical 2, 4 radical 2, because the legs are always the same. Try this one. What's 4 divided by radical 2? 4 divided by radical 2 is 2 radical 2. Do you see a pattern? Do you see a pattern? What do you think 6 divided by radical 2 would be? Well, I hope you said 3 radical 2. 3 radical 2. I hope you're noticing it's just half of the number with a radical 2 next to it. Let me explain to you why, because you probably didn't get to see this in Algebra 1, maybe. In math, we cannot have a radical on the bottom. So in order to eliminate the radical on the bottom, you multiply the top and the bottom by that radical. So this is just multiplying by 1. You can multiply anything by 1 and it doesn't change the value. So I'm going to multiply the top and the bottom by that radical 2. So I would be left with 8 times radical 2, which is 8 radical 2. And then radical 2 times radical 2 is radical 4. But what is the square root of 4? Well, it's 2. How many times does 2 go into 8? 4. So that's why it's half the number with a radical 2. So if you can just remember that. But what if the number's odd? What if it's 9? When I type in my calculator 9 divided by radical 2, look what it does. 9 radical 2 over 2. It's because 2 does not go into 9 evenly. So it is 9 radical 2 over 2. 9 radical 2 over 2. Now, if you put 4.5 radical 2, I wouldn't count it wrong. So just so you know that. But proper way is 9 radical 2 over 2. Which really, this is 6 radical 2 over 2. It just reduces to 3 radical 2. And this is really 4 radical 2 over 2. It just reduces to 2 radical 2. Okay, so I hope you are feeling okay with 45, 45, 90 triangles. Just remember that the legs are always the same, and the hypotenuse is the leg times radical 2. If you know the hypotenuse, to go backwards, you divide by radical 2. Let's talk about 30, 60, 90. So now you're going to want the side of your notes page that has 30, 60, 90. And again, I've got these additional notes. So this front side is 45, 45, 90. The back side has 30, 60, 90 rules. Okay, so a 30, 60, 90 triangle is based on a equilateral triangle where every side is 2. So equilateral means all 3 angles are 60, all 3 sides are the same, and they happen to be 2 on this one. Okay, so if I were to draw in the altitude, the height, that's going to divide that top 60-degree angles into 30-degree angles each. So I'm left with a 30, 60, 90 triangle, which would make the hypotenuse still 2, but that short leg is now 1 because I divided the 2 in half. So on a 30, 60, 90 triangle, we always have a short leg, a long leg, and a hypotenuse. The hypotenuse is the easiest one to find because it's across from the right angle. The short leg is always across from the 30-degree angle because 30 is smaller than 60. The long leg is across from the 60-degree angle because 60 is bigger. So you've got a short leg, a long leg, and a hypotenuse on all 30, 60, 90 triangles. So right now, I've divided my equilateral triangle in half. My hypotenuse is 2, and my short leg is 1. So we could do Pythagorean Theorem to find that missing side. Now this time I know the hypotenuse. So if you know the hypotenuse, which is the longest side, you have to subtract to get a smaller side. So I would do the square root of 2 squared minus 1 squared. So square root 2 squared minus 1 squared, and you get radical 3. So the long leg is now radical 3. So this is how I remember. 1, 2, radical 3 is because it's a 30, 60, 90. 3 different angles, 1, 2, radical 3. So you don't get that confused with the 45, 45, 90 because those rules are different. So now, not all sides are 1 and 2 and radical 3. So since we don't know the lengths of all sides, everything will always revolve around the short leg. We'll call the short leg X. The hypotenuse is always 2 times the short leg. So you got to remember that. 2 times. Hypotenuse, 2 times the short leg. The long leg is always radical 3 times the short leg. So everything revolves around the short leg. Short leg times 2 for the hypotenuse. Short leg times radical 3 for the long leg. So let's try one. My short leg is 4. Everything revolves around the short leg. So my hypotenuse, do you remember what to multiply by for the hypotenuse? Hypotenuse is times 2, so my hypotenuse would be 8. My long leg is the short leg times, do you remember? Times radical 3. So 4 times radical 3 is just 4 radical 3. So let's try a few. If I know the short leg, everything is much easier because everything revolves around the short leg. So to get the hypotenuse, it's just short leg times 2. 5 times 2, 10. 7 times 2, 14. Radical 3 times 2, 2 radical 3. Radical 10 times 2, 2 radical 10. I can't multiply because they're not both under radical. Okay, now to get the long leg, it's the short leg times radical 3. So 5 times radical 3 would just be 5 radical 3. Remember to always go back to the short leg though. Don't use the hypotenuse. Everything revolves around the short leg. So 7 short leg, 7 times radical 3 is 7 radical 3. What do you think radical 3 times radical 3 is? Well, since they're both under radical, we can multiply them together, which would be the square root of 9. Do you know what the square root of 9 is? That is 3, because 3 times 3 is 9. What about this one? Radical 10 times radical 3. Well, that's just radical 30. That's not a perfect square, so I just leave it as radical 30. If you're unsure, you can always use the calculator. Radical 30 is radical 30. And you could even multiply it out. So it's easy if you know the short leg. What if, though, you know the hypotenuse? Well, to get the hypotenuse, we multiply by 2. So if we go backwards from the hypotenuse, we would have to divide by 2. So what's 22 divided by 2? Oh, I thought it was on there. 22 divided by 2 is just 11. Now that we have the short leg, to get the long leg, do short leg times radical 3, 11 radical 3. Okay. Let's try some. On all of these, I know the hypotenuse. So to get the short leg, take the hypotenuse and divide by 2 this time. So 4 divided by 2 is 2. 18 divided by 2 is 9. 30 divided by 2 is 15. Once you know the short leg, the long leg is just the short leg times radical 3. So 2 times radical 3, 2 radical 3. 9 times radical 3, 9 radical 3. 15 times radical 3, 15 radical 3. Okay, but what if we don't know the hypotenuse or the short leg? What if we have to go backwards from the long leg? So the long leg, we're multiplying times radical 3. So if we know the long leg, to go backwards, we divide by radical 3. So just like with the radical 2's and they cancel, same with the radical 3's. 23 radical 3 divided by radical 3, since both of those are radical 3's, they cancel, and I'm left with 23. And then the hypotenuse is the short leg times 2. 23 times 2 is 46. Okay. So I know the long leg is 14 radical 3. To go backwards, 14 radical 3 divided by radical 3, the radical 3's cancel, and I have 14. Now I can get the hypotenuse by just taking the short leg times 2, 28. So let's look at this one. 16 radical 3 divided by radical 3, the radical 3's cancel, and I'm left with 16. 16 times 2 to get the hypotenuse is 32. But what if it's not a radical 3? What if it's a whole number? So let's try this. Let's do 9. To go backwards, we divide by radical 3. What's 9 divided by radical 3? 9 divided by radical 3 is 3 radical 3. 3 radical 3. Let's try 12. What's 12 divided by radical 3? That's 4 radical 3. 4 radical 3. What's 27 divided by radical 3? 9 radical 3. Are you seeing a pattern? Well, you just take the number, divide it by 3, and then put a radical 3 next to it. So 9 divided by 3 is 3, 3 radical 3. 12 divided by 3 is 4, 4 radical 3. 27 divided by 3 is 9, 9 radical 3. But what about 14? 3 doesn't go into 14. So look what your calculator does. 14 divided by radical 3 is 14 radical 3 over 3. 14 radical 3 over 3. It's because on all of these, remember, you can't have a radical on the bottom. So I would have to multiply the top and the bottom by radical 3 to eliminate that. So 9 times radical 3 is 9 radical 3. Radical 3 times radical 3 is radical 9. But what is the square root of 9? It is 3. And 3 goes into 9 3 times. So here, 14 divided by radical 3, if I multiply the top and bottom by radical 3, 14 times radical 3 is 14 radical 3. Radical 3 times radical 3 is radical 9, but the square root of 9 is really 3. So that's where we got that. So what about 25? What do you think 25 divided by radical 3 would be? Well, it would be 25 radical 3 over 3. Now to get the hypotenuse, you just multiply by 2. So I just take your whole number and multiply it by 2 because I can't multiply the radical by 2 because the 2 is not under radical. So just the whole numbers multiply together. So 3 times 2 is 6. It would just be 6 radical 3. 4 times 2 is 8, 8 radical 3. So don't leave off the radical. It would be like doing 4x times 2. That would be 8x. So keep the radical there. 9 times 2 is 18, 18 radical 3. Again, take that whole number times 2. So 14 times 2 is 28, but it's radical 3 over 3. So make sure you take the rest of it. 25 times 2 is 50, 50 radical 3 over 3. So those are your 30, 60, 90 rules. I know that's a lot to take in. It's going to take a lot of practice, but you're going to have to memorize all those rules. And we'll talk about the other on your assignment. So hopefully you don't cry completing your assignment. Anyway, 45, 45, 90 rules. The legs are the same. Hypotenuse is leg times radical 2. And I remember radical 2 because there's 2 45s. 30, 60, 90. Everything revolves around the short leg. The hypotenuse is times 2. The long leg is times short leg times radical 3.